Welcome to the Deep Dive. This is where we take your sources, could be articles, research, maybe even your notes, and we really plunge in.
Yeah, we sift through them to pull out the most important bits.
Exactly. The idea is to give you that shortcut to being, properly informed, maybe find some surprising facts, keep it interesting.
Keep you hooked.
Right. And today, today's mission is a bit unique. We're aiming to get you up to speed and fast on three areas that seem pretty separate at first glance.
Uh-huh. They seem disparate, but they're all compelling. We're diving into climate change, tipping points, those points of no return.
Okay.
Then we'll look at surveillance tech, some really cutting-edge stuff, maybe slightly unsettling advancements there.
Right. And the third?
And then the science behind our nightmares, which is surprisingly fascinating.
Nightmares, okay. Quite a mix.
It is. But the goal is to find those crucial nuggets in your material, maybe spot some unexpected links.
And have you connect the dots
Right.
without getting lost in all the information.
Exactly. Understanding those hidden patterns.
Okay, let's start with the big one then. Earth's climate and these tipping points.
Yeah.
So just so we're clear, when we talk about tipping points here, it's not just things changing slowly over time.
No, not at all. Think of them as thresholds. Critical thresholds. Once you cross them, you trigger these really dramatic, self-sustaining shifts. Things kind of run away on their own.
Self-sustaining.
Yeah.
Wow. And I guess the hard part is figuring out, well, how close are we?
That's the challenge, yeah. Pinpointing it is tough.
And your sources highlight how interconnected everything is,
Yeah.
like the Amazon rainforest.
Exactly. The Amazon's a key example in the material. It's, more than just trees. It actually helps create its own climate.
How does it do that? Photosynthesis.
Photosynthesis and transpiration, yeah. It pumps out moisture, stores billions of tons of carbon. It's a huge regulator.
Okay.
But the research shows how things like deforestation,
Yeah.
Chainsaws, clearing land really disrupt that balance.
Right, so less forest means
Less rainfall, temperatures creep up, you get more fires. It can lead to something they're calling Amazon dieback.
dieback. Sounds ominous.
It is. It's essentially a massive climate change-driven defoliation. Trees just can't cope with the prolonged drought and heat.
And it turns it to
It risks transforming the whole thing into a dry savanna.
from rainforest to savanna. That's a massive shift. And the sources called it self-sustaining and irreversible.
That's the term used, yeah. Which really brings home the urgency, doesn't it? What happens after you cross that point?
Yeah, absolutely. Another big one mentioned is the Greenland ice sheet, the Greatar S.
Mm-hmm. Greenland. Its melting is a huge concern for sea levels. We're talking potentially more than 7 meters of rise globally if it all went.
7 meters.
Yeah.
Just let that sink in.
It's enormous. And then there's AMOC.
AMOC. That's the Atlantic Meridional Returning Circulation.
That's the one. It's this massive ocean current system, kind of like a conveyor belt carrying heat. It's what keeps northern Europe relatively warm.
Okay. And the worry is
The worry is that it could get disrupted, maybe even shut down. That could lead to, dramatic cooling in Europe. Huge impacts on farming, for instance.
wow. So Amazon, Greenland, AMOC, any others mentioned?
Yeah, the sources list quite a few potential ones. Boreal forests dying back, coral reefs collapsing,
Coral reefs, right.
the West Antarctic ice sheet, parts of the East Antarctic one, too, especially areas in these subglacial basins.
Meaning they're below sea level.
Exactly, makes them more vulnerable to warm ocean water. Also, permafrost thaw, releasing trapped greenhouse gases, both northern and southern permafrost. Even the collapse of Lake Chad is mentioned.
Okay, so there's this whole list of potential dominoes. But how sure are we about when they might fall?
That's the really difficult bit. Prediction is incredibly hard. Different models give different timelines, different sensitivities.
Salts of uncertainty.
Definitely. And some perspectives in your sources even suggest that for things like the AMOC or maybe the Amazon, we might have already crossed certain thresholds.
All right.
It brings us back to those global temperature targets, the 1.5 degrees C goal. But if these tipping points are closer or have lower thresholds, some argue we might already be in the territory for triggering things associated with 2 degrees C or even 3 degrees C.
Which makes understanding the mechanics behind it all even more critical.
Yeah.
You mentioned feedback loops earlier.
Right. Feedback loops are key. They're processes that can either amplify the change, make it worse, that's positive feedback, or dampen it down, that's negative feedback.
Okay, so give me an example of a positive feedback loop, one that makes things worse.
Forest fires are a classic one. Fires release CO2, obviously, but they also destroy trees that absorb CO2. Plus, burnt ground is darker, absorbs more heat.
Leading to conditions for more fires, a vicious cycle.
Exactly. Or think about Arctic sea ice melting. White ice reflects sunlight, keeps things cool. Dark ocean water absorbs sunlight, heats things up, melts more ice.
Oh, okay. I see.
And a really potent one is thawing permafrost releasing methane. Methane's a much stronger greenhouse gas than CO2, especially in the short term. So that really cranks up the warming.
Okay, those sound pretty scary. Are there any natural breaks, negative feedback that could slow things down?
Well, there are potential ones, yeah. Though how much they can counteract the current warming is still debated. Your sources mention things like maybe increased cloud formation could reflect more sunlight, creating a cooling effect.
Clouds reflecting light.
Okay, and there's research like from the University of Washington looking into how moisture in the lower atmosphere might increase cloud cover. That could be a negative feedback.
Interesting.
On a much smaller scale, think about air conditioning. It cools your house.
But pumps heat outside.
Exactly. Local cooling inside, but actually adds heat to the surroundings. So negative feedback locally, but not globally helpful.
Right. It's amazing the effort going into tracking all this. The sources talk about some really advanced monitoring, like Britain's ARAA agency.
Yeah, the Advanced Research and Innovation Agency, they've got this $25 million 5-year project just for developing new sensing systems.
And they're doing what? Fishing for bubbles on the Greenland ice sheet?
Literally. Using acoustic sensors to listen for bubbles released by melting ice, trying to map underwater currents that way. It's pretty ingenious.
That is clever.
What else? We're seeing arrays of buoys deployed in the North Atlantic, specifically to keep an eye on that AMOC current system.
Okay.
And then there's the use of these tiny self-sailing robots, solar-powered, loaded with sensors.
Like little autonomous boats.
Exactly. Plus, drones getting right up close to icebergs and glaciers to monitor them in detail. It's all about getting better real-time data on these critical systems.
So pulling this together, why is this crucial for you, listening? Understanding these huge, complex systems, these tipping points.
Well, it really highlights the global scale of the implications, doesn't it? These aren't abstract scientific concepts. They affect everyone.
And it also underlines why, thinking critically is so vital. In a world just flooded with information, being able to sort the signal from the noise on topics like this, it's essential.
Absolutely.
Okay, so from that massive planetary scale, let's zoom right in to technology and, well, how it's changing our personal space, maybe our privacy. These eyes in the sky are getting closer, aren't they?
They really are. We're moving way beyond just standard CCTV or basic facial recognition now.
Yeah. How so?
The material talks about whole-body biometric recognition. Companies like Farsight, for example, are developing AI that can apparently recognize people from a distance, even through obstacles sometimes.
Through obstacles. Like walls?
Maybe not solid walls easily, but potentially foliage or identifying someone from a partial view. The AI is trained on these enormous data sets. One example mentioned was 870,000 videos, thousands of images from 3D scans.
Whoa. So it's not just looking at my face.
Nope. It's analyzing your gait, how you walk, your posture, your overall body shape. It's building a much more complete picture, even if it can't see your face clearly.
How does it technically do that?
It uses sophisticated 3D algorithms. Basically, it tries to reconstruct a 3D model of you from 2D video footage that lets it analyze fine-grained features, body shape, movement patterns. And they're even using large language models, like the tech behind things like ChatGPT from OpenAI, to help describe what's happening in the video content, adding another layer of understanding.
Okay, so where is this tech actually being used? Or explored?
Well, the applications mentioned are things like crime solving, improving public safety, identifying specific individuals in crowded places.
Right.
Your sources cite specific locations where this is being deployed or discussed big cities like New York, London, Verona in Italy, too.
And there was a quote about a full-body recognition system.
Yeah, from Ryan Stilberg at Veritone, talking about systems that can match people based on things like their body shape, how they walk, not just their face.
It definitely opens up new avenues for security, identification.
Oh, sure.
But it also really brings up some big questions, doesn't it? About privacy, civil liberties, as these tools get more powerful and more common.
Absolutely. It's a conversation we need to be having. The tech is moving fast, and the implications are significant for everyone.
Okay, so from global systems and pervasive tech, let's shift again to something really personal. nightmares.
Yeah, the science of nightmares, and it's more widespread than you might think. The sources say about 1 in 20 adults have frequent nightmares.
1 in 20, that's quite a lot.
It is, and the research scale is pretty impressive too. You mentioned the 870,000 videos earlier. Some of that data relates to analyzing nightmares.
Okay, but what's the really surprising insight here?
The core finding really is how often nightmares seem to be linked to underlying health conditions, not just psychological stuff, but physical health too.
Okay, wait, so beyond things like PTSD, anxiety, depression, insomnia, which kind of makes sense.
Right, those connections are known. But the research also points to links with chronic pain and even potentially more serious things,
Oh boy.
like heart disease, stroke, diabetes, dementia, even autoimmune or neurological disorders.
Wow, really?
Hmm.
Nightmares linked to heart disease.
Yeah. There's specific research cited from a Dr. Andra finding that people who had frequent nightmares actually had a significantly higher risk of developing heart disease, having a stroke, and even dying earlier.
That's quite startling.
It leads to this really powerful idea, this hypothesis. Could frequent disturbing nightmares actually be an early warning sign?
A warning from your own body or mind.
Potentially, yeah. Flagging physical or mental health issues before other symptoms become obvious, it could prompt people to seek help earlier.
Which could make a huge difference, getting intervention sooner.
Exactly. Imagine your brain trying to tell you something's wrong long before you consciously feel it physically.
But there's a nuance here, isn't there? The sources say nightmares aren't always bad.
Right, that's a fascinating flip side. While they're often linked to illness or distress, they can sometimes serve a different purpose, like a coping mechanism.
A coping mechanism.
Almost like a release valve for stress or trauma. You know, processing difficult experiences or intense emotions during sleep, maybe preventing them from overwhelming you when you're awake.
So your brain is kind of working things out,
Yeah,
even in a scary way.
that's one way to think about it, yeah. It raises interesting questions about how we interpret these dreams.
And are there ways to treat persistent bad nightmares?
Yes, definitely. The material mentions therapeutic approaches like imagery rehearsal therapy, IRT. That's where you actively rewrite the nightmare narrative while awake to make it less distressing.
Ah, so you changed the story.
Kind of, yeah. And there are also medications like prazosin that can sometimes help by calming down that fight or flight response that often fuels intense nightmares.
So understanding nightmares better isn't just academic. It could actually change medical practice.
It really could. It offers this fresh perspective, taking something common like dreaming and seeing its potential as a diagnostic tool, maybe even a therapeutic one.
It makes you think, doesn't it?
Yeah,
About your own dreams, what they might be reflecting about your well-being.
absolutely. Our minds and bodies communicate in such complex, sometimes unexpected ways.
Well, that was quite a journey. A real deep dive, you could say.
Definitely. We went from these huge planetary systems, climate change.
Right, the tipping points, the feedback loops, then zoomed into cutting-edge AI, surveillance.
The whole body recognition stuff, yeah.
And then right down into the human mind.
Yeah.
The surprising science behind nightmares.
It really ties together in a way, how things that seem totally separate, global climate patterns, ocean currents, algorithms, watching crowds, even the stories in your dreams,
Yeah.
they're all increasingly being viewed through this lens of complex systems, interconnectedness, and what we can learn from analyzing data patterns within them.
That's a great point. It makes you wonder.
What other hidden connections are out there?
Exactly. What other links exist between fields that seem completely unrelated right now? And if we uncover them, how could that help us navigate, well, everything that's changing so fast?
That's the thought to ponder, isn't it? How understanding those connections might empower us.